Examine the topology on the left-hand side. What do we have? We have a single subnet, 192.168.1.0/24, and a single VLAN, VLAN 1 in this case. Our goal is to prevent communication between PC1 and PC2. So if PC1 tries to send traffic to PC2, nope, it's stopped. PC2 tries to send traffic to PC1, it's stopped as well. So we do not desire the communication between PC1 and PC2. However, we still want to make sure that PC1 and PC2 can access the server that is up here. Why might you want to do this? Well, let's say we have a big conference. We have a lot of different vendors and partners and providers all showing up at this big conference. Everyone needs access to the internet. They need access to a video streaming server that's being set up in the conference. However, we want to make sure that all of the customers, clients, providers, whoever is there at the conference, they are protected, meaning that their traffic that they are generating does not end up going to other devices within that conference and vice versa. So we really want to separate everybody out, but we do not want to have to do what we see on the right-hand side to accomplish it. We do not want to create a separate VLAN for every single customer provider that is there. Meaning, we do not want to create a separate subnet. So down here, I would have to readdress all of these different clients. Because now everybody in VLAN 2 has to have a completely different IP address. So 192.168.2.1 is an example. And then everybody in VLAN 3 and VLAN 4 and VLAN 5 and so on and so forth, they'd all have a different subnet that they belong to. So the addressing can get a little crazy here. And the number of VLANs could get crazy as well. What are we going to have to set up on the router now? A whole bunch of sub-interfaces. One for each and every single VLAN. So instead of creating all these different sub-interfaces on the router and mapping VLANs to IP addresses, why not just keep that single VLAN, that single subnet, have everybody in that same VLAN subnet, but then start to subdivide up the VLAN into multiple smaller VLANs? Remember, a switch is only going to allow traffic that arrives inbound on an interface that belongs to a VLAN to go to other interfaces that belong to the exact same VLAN. So if we had our main VLAN, our primary VLAN, and our IP address is associated, or our subnet is associated with that particular VLAN, 192.168.1.0/24, we've mapped it in our documentation of VLAN 1. So everybody's in that. But then if we start carving up the interfaces and saying, all right, so even though you are in VLAN 1, we are now placing you in a secondary, smaller sub-VLAN. So we're placing you in a VLAN within a VLAN. Well, that's what private VLANs are about. So in this case, this interface is part of private VLAN 500, which is a member of that primary VLAN of 1. This interface is a member of private VLAN 505, which is a member of that primary VLAN of VLAN 1. Notice the addressing is the same. We haven't modified the addressing whatsoever in this case. So within this private VLAN architecture, everybody's within the same subnet that is connected off this router interface. And from here, the suppression of communication between interfaces is based on the fact that they belong to either the same private VLAN or different private VLANs. So you belong to different private VLANs? Nope, sorry. Communication is not possible. But if you belong to the same private VLAN, especially if it's a community VLAN, then you would be able to communicate within that particular private VLAN that exists. So this is the concept of private VLANs. Instead of having to readdress the network to segregate those devices from each other, you can simply add these private VLANs, so VLANs within a VLAN, to accomplish the same goal without having to modify the overall primary VLAN and the IP addressing that goes along with it.